Ladies and gentlemen, the story you are about to see is true. The names have been changed to protect the innocent.
Okay, here we are, Johnny on the spot with the with the teenage super sleuths. And once again, we're looking into the science of this quote-unquote science or sophistry of global warming. And the teenage super sleuths are on a quest to empower the classroom and for the students to look for the data themselves. Don't listen to your teacher. Start questioning authority. We want to start a classroom rebellion. We want children seeking the truth, not listening to propaganda. And so what you've done today is you've told me about this program called ModTran, which is actually how you model the climate. Is that right?
Yep.
And you wanted to give just a brief background, and we're going to dig into this deeper in future videos, but you want people to be aware of how they can go test some of these theories and measure what the impact of CO2 is going to be, right? Mm-hmm. All right, yep. Well, this is ModTran, and what you're telling me here is this is the level of CO2 in the atmosphere. Right now it's about 400. This is the level of methane, and this is what they're talking about when they talk about cows passing gas and things like that. You know, but you know what? People pass gas as well. So if there's a problem with cows passing gas, people pass gas too. You know, environmentalists pass gas. Okay, so here's the tropospheric ozone. This is the stratospheric ozone. This is the water vapor. Now the water vapor is a little complex, and what you do is you can go over here and see this water vapor millibars. You can figure out what a cloudy day or a humid day would be, and then you can enter it by a percentage over here. So like you could enter like 1.1 or 1.3, and then Freon, and then the temperature offset. Now this temperature is set for, I think it's the ground temperature is 300. I think that's actually about 80 degrees Fahrenheit, or about a little bit warmer than room temperature.
So this would be about average summer day, you'd say? Yeah,
let's actually just check something out. 300 K in C. Okay, so what we're talking about, it's about 26 degrees Celsius, and that is 80 degrees Fahrenheit. That's kind of hot, right? And so I think what we want is about 290 Celsius. Yeah, we want about 290. No, that's going to be K.
Yeah.
290 K. I think that's about room temperature. So when you're dealing with ModTran, you might want to have a temperature offset of -10. Okay, and so that's more room temperature.
That's just a bit below room temperature.
Okay? Now here's water vapor pressure or relative humidity. Right now it's using millibars, so that's pressure. Now you got to choose your location. Okay, here's where you want. Let's just use tropical atmosphere. Okay, no rain or clouds. And this is the altitude. Now this is 70 meters looking down. So this is the entire atmosphere, but what we're concerned about is the lower atmosphere. So why don't we change this to 0.1 kilometer, and we're not going to look down. We want to be concerned about looking up. Okay, we want to see what the back radiation is. Okay, so what is CO2 pushing back at us? All right, and so here we've set everything up, and you can see the downward IR heat flux is 326. That's the energy that's coming back from the energy. That's the global warming effect. When they talk about the greenhouse gas effect, that's what it is. So this is the greenhouse gas effect. It's the long wave radiation coming back. All right, now we're going to save this run to the background. Okay, now I'm going to click that. Okay, now what we're going to do is we're going to go change a setting, and we're going to change watch what happens down here. Now let's just say we have a simple cloudy day. Watch this. Okay, the difference now, we went from 389 to 326.
Ooh.
Right?
Got a lot cooler, didn't it?
Well,
yeah.
It got, no, actually that's getting warmer. Okay? Okay, so what you're seeing though is the infrared radiation went back. Now why did that happen? Because water vapor is the most potent greenhouse gas. Mm-hmm. Most people don't know that. But you can see it changed by 62 watts per meter squared. Now that's what the back radiation is measured in. And a watt is basically a flow of energy, and a meter squared is just an area. So what you can see is by adding water vapor, a lot of energy starts getting back. So let's go and let's get rid of those clouds. Okay? See, now we're back to zeros. Okay? Now what you're saying is let's double CO2 from 400 to 800. Now watch this. Did you see that?
No.
This is, if you doubled CO2, this is all the energy you're going to get additionally to the system. That's why I'm saying that linear temperature trend doesn't make sense, because you can double CO2 and it barely changes the amount of energy you absorb.
Barely changes.
Less than 1.
Less than 1. Now remember, watch what happens when we change it to a cloudy day. 62. Right? So just a simple cloudy day blows away anything CO2 could ever hope to do.
Yeah.
Now, right there just goes to show you that the marginal change in energy by additional CO2 is basically negligible.
One extra cloudy day in a year would have more impact.
Way
than CO2.
more. Yeah, and so
Unbelievably
Mother
more.
Nature has no trouble handling cloudy days. She can certainly have no trouble handling slight increases in atmospheric energy from CO2. Now remember also, this is a flow of energy, right? And so this is like a garden hose, whereas a cloudy day is like a pipeline, an oil pipeline.
Yes.
Right? And so one cloudy day can take away many, 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 many days of CO2.
Can you add some rain in there and see what happens?
Well, yeah, you can do a whole bunch of stuff here. Yeah, that's a good point. Let's add some rain. Let's boost the water vapor substantially. Now watch what happens here. Well, that was happening because of the rain. Let's get rid of this. Okay, now the water vapor. Okay, so as you can see, as we change this water vapor to, let's say, a very humid day, okay, you can see this changes dramatically.
Significant
Yeah.
effect.
Now let's go take a look at the impact of CO2, how it really is. So let's go ahead and delete the background, and let's just go see what CO2 does. Let's change CO2 to 0. Okay? And we put everything back to just basically normal. Okay? So this is what the atmosphere looks like. And let's change this looking down. Let's just go looking down from 70 kilometers. Let's just do the full atmosphere. And this is what they're talking about. So this is the atmosphere with no CO2. Okay, I'm going to save this to the background. All right? So this is basically what the atmosphere looks like. And you can see these little blips here.
Yeah.
Okay, this is basically 15 microns is where CO2, the wavelength around 15 microns is where you should see a dip here as we add CO2. So let's add CO2, and let's go to the pre-industrial level, or this is the level of CO2 where plants die. So when I do that, see how this blip down all of a sudden?
Yes.
That's CO2. That's what the CO2 is absorbing, right? Okay, so this is the lowest plants get. Now let's go to
all-time high.
Yeah, but as you can see, delete background and store it here. So this is where let's say this is our starting point. This is theoretically the lowest CO2 could have been. All right. So then let's go from 280 or 180 to 280, and this is the pre-industrial level. Okay. So the pre-industrial level added another 1.85 watts per meter squared. Okay. All right. So let's go ahead and delete the background one, and now save it back there again. And now let's take 280 to 400. Okay? So as you can say, it's only additional 1.48. Okay? And so that's all the industrial age, all it really did was add that additional 1.48 watts per meter squared.
Which isn't a lot.
Which isn't a lot. And like I said, if you simply change this to adding a cloud, it totally blows it away. Simple cloud.
Completely.
So this is called ModTran, and you wanted to make sure that all the people watching the video knew how to use this.
Go ahead.
They should get there when you're in the classroom. Make sure you get this program up. It's on the University of Chicago, and you were saying that they should have this thing open so they can ask teachers tough questions in the classroom.
Teachers be like, "Hey, when I look at this,
Yeah, well, help me understand this.
How come CO2 has less effect than a cloudy day? Significantly less.
Bingo. Now, are you telling me that Mother Nature can't handle an additional CO2, but she can handle rainy days every other day, losing tons and tons of energy compared to where we are? All right, so let's like, share, subscribe, comment, right?
Yes.
Be sure to check back because we're going to keep digging. We're going to find the truth. We want you to start the classroom rebellion, start speaking power to truth, and once again, in a free society, you should never fear speaking the truth. And that's what we're all about,
And
right?
most importantly, don't forget to subscribe so you don't miss our next clip.
Yeah, and if you see Professor Yeats and Lizzie...
You see, the climate change alarmists are not just scientifically wrong and often scientifically illiterate. They are insane.